Today we're going to look at section 3.6b, transposing matrices. Our objectives are to be able to transpose a matrix on a graphing calculator, to be able to identify when a matrix needs transposing, and to be able to label the product of matrices. So what does it mean to transpose a matrix? Well, all it means is we turn all of the rows of a given matrix into the columns and vice versa. So for example, if I have a 4 by 2 matrix, my rows and my columns, transposing it changes it to a 2 by 4 matrix. All it does is it switches the rows and columns, and it's going to be very useful when we get to multiplying. So how do we actually do this on the graphing calculator? So let me move one over here for you. Whether you have a TI-83 or TI-84, all of the matrix calculations should be right above the x to the -1 button, which is the fourth button down on the left-hand side. Mine happens to be yellow because it matches with my yellow second key. If, for example, you have a blue second key, this would be a blue matrix. So I'm going to hit second and then x -1, and that gives me my matrix menu. Now, I don't have any numbers in here. You might have different numbers in here, the orders of each of these matrices, which is fine because all we ever do is just rewrite over a matrix. Unless you clear your memory, these will usually have something in it. There are three columns. The first one is names, and that allows us to put a matrix onto our home page. The next one is math. That gives us all the different operations we can do with our matrices. What we're going to be dealing with today is number 2, this tiny t for transpose. And we're also going to deal with edit. Edit is how you change what the values or entries are for a matrix to tell the calculator. So, why would we actually need to transpose a matrix? Well, if you remember from our last lesson, just multiplying matrices by hand, if, for example, I had that 4 by 2 matrix, the only way you can multiply matrices is if the column of the first matrix is exactly the same as the row of the second. Well, what if I have a 4 by 2 and a 3 by 2? Let's pretend like they're all in the same unit so we don't have to worry about it. Well, I wouldn't be able to multiply these. But if I transpose this one, what that means is it makes it a 2 by 3. Now these have the same rows and columns, so I could multiply these and end up with a solution that's a 4 by 3, and that's what we're going to deal with today. So let's look at our first example. I'm going to give you matrix A is the amount of spiritware sold at 2 sporting events, and matrix B gives the cost of each of those items. So before you start dealing with the calculator at all, what you want to do is take a second to actually analyze what this matrix gives us. This matrix happens to be a 3 by 2 matrix, 3 rows, 2 columns. And when you get to word problems, it's always best to not only put the value of the order, but to actually use the units as well. So we have t-shirt, hoodie, and sweats, and I'm going to call that our apparel. Okay, and we know that it's apparel by, and if we look at basketball and football, the type of game. And you can call them different things, but that's what I'm going to choose to call them. When I get over to matrix B, this is a 1 by 3 matrix, 1 row, 3 columns, and the units, my 1 is cost. You could write money if you'd like. By, and if I look at the top, that's my apparel. This is going to come in very useful, especially when the problems get more complicated. So the first thing says find and label the product, so that means we're multiplying, of the 2 matrices. Well, if I look at matrix A and matrix B right now, I can't multiply them the way they are. So if I write matrix A times matrix B, this is not going to work because I can't multiply a 3 by 2 by a 1 by 3. But if I transpose this matrix by putting a little t here, that becomes a 2 by 3 matrix. And that flips it. Now it's game by the apparel. And if I look at matrix B and I transpose it, that now becomes a 3 by 1 matrix. And if I transpose it, the units transpose, so this is apparel by cost. Now I can actually multiply these together because the actual value of the column of the first and the row of the second are the same, and the units, they're both apparel. So now I can multiply these together. And when I multiply them, I should get a solution that's 2 by 1 from what we did by hand. So I'm going to get 2 rows and 1 column, and I can look here and see what my solution is going to be. The first, my rows, are going to be the games. Well, even though my games originally were on the column, so horizontal, and now they're becoming vertical, you still go in the same order. Basketball came first, then football. My column comes from here, cost. So if I do this correctly in my calculator, I should be able to fill in those two values. So let me show you how I would do that. To remind you how I got to this, I'm going to hit second and then the x-1 button. And I'm going to go over to edit. You can hit right twice or left once. And I'm going to hit enter. I always like to put all my matrices in A and B, or if I have 3 A, B, and C, 4 A, B, C, and D. There's no reason, even if I call this P, don't scroll all the way down to P. That's not worth it. So my first matrix, I said, is a 3 by 2. We always hit enter after every number we hit in. And the nice thing about the calculator is when you put 3 by 2, it actually draws it out as a 3 by 2. So if what you have on your paper does not match your calculator, you've messed up typing in the order. So I'm just going to type this in again. It does the rows first, so 5 and 7. Then we get 4 and 9, and then 3, 8. This is the most important thing. Make sure you hit enter after that last entry. A lot of people just type it in here, don't hit enter, and then wonder why their answer is wrong. It's because it doesn't actually go in until you hit enter. I'm going to quit this and go back into matrices, and I'm going to now edit my B matrix. That was a 1 by 3, which is 15, 30, and 20. Okay, so I'm going to quit, second mode quits. So now what I wanted to do is type in exactly what I see on my paper. So I need to go back into matrices, and I want to put the name A on my home screen. And whatever you type in should look exactly like what's on your paper. To get to the little t, I'm going to go over to math. It's my second option. I'm going to multiply it, go back into matrix. I need b, which I'm going to go down to 2, and then go back in. The only thing annoying is you do have to keep going back in and out of this different menu. But other than that, it saves you a lot of time when you don't have to do it by hand. So now this looks exactly like what I have in my sheet. Going to hit enter, and it gives me two values. It gives me 255 and 535. So, what is it now asking? In words, describe what your solution means. Well, what we now have is the total money made at each game. And that's all you need to write. Now you could write it a couple different ways, but this will work for me. So total money made at the games. Okay. All right. And you could say total money made on apparel at games, however you want to do it, but again, this is the money made and my two games. So let's look at the second example. This one's going to be a little bit harder because they actually don't give us the matrices. We have to do them all by hand. So it says tickets for a play cost $2 for students, $5 for adults, and $4 for senior citizens. At Friday's show, there were 121 students, 64 adults, and 32 senior citizens. At Saturday's show, there were 183 students, 240 adults, and 25 senior citizens. So the first thing we need to do is write and label two matrices for this information. So let's get our first one from our first line. We actually have two pieces of information here. We have the cost and what type of person went to the play. So that's how I'm going to do this. I'm going to do cost of the ticket, and we have three types of people. I'm going to abbreviate it: student, adults, and senior citizen. Okay. And you could write them out fully if you'd like. So I know the students pay $2, the adults $5, and the senior citizens $4. My second piece of information talks about how many tickets for each type of person were sold on the two different days. So I know that I had two different shows. One was Friday night, the other was Saturday night. And again, I have my types of people, my students, my adults, and my senior citizens. At Friday's show, we had 121, 64, and 32 respectively. And then Saturday, we had 183, 240, and 25 respectively. So those two matrices with the label satisfies the first part. But now it says find and label the product of the two matrices. So before I go on, I actually want to kind of analyze these matrices to see what I have. The first one is a 1 by 3 matrix. And I'm going to call this cost by people, the type of people who went. Okay. And if I look at the second one, I have the day of the week by the type of people who went. Okay. So if I look at this right now, and again, this is a 2 by 3, I can't multiply it in the current state because 3 and 2 aren't the same and people and day aren't the same. But if you look at this matrix, and I'm going to call this one matrix B for our calculator, and I'll call this one matrix A. If I transpose the B matrix, I'm going to have 3 as the row, which matches up, and I'm going to have people as my unit, which matches up. So I'm going to take matrix A, which is a 1 by 3, and it's cost by people, and I'm going to multiply it by matrix B transposed, which makes it a 3 by 2, which takes it to people by day. Okay, and I like to just write this out to do a check. The 3's match up and the units match up. So I'm going to go back to my calculator. Okay. I'm going to clear out my main screen, and I'm going to go back into matrix. We're just going to do one more practice of trying to type this in. So I'm going to hit enter. Again, we're just going to write right over it. So this is a 1 by 3, and I have 2, 5, and 4. Okay, I'm going to quit by going second mode, go back into matrix, go to edit, and I'm just going to rewrite over the B, which was a 2 by 3, and then just type in all of these. And again, remember, it goes left to right first and then fills in the next row. Okay, again, hit enter after that last one. So I have them all typed in, and now I can quit. Okay. So, because I've written it out, all I do is have to match up with what I have on my paper with what's on the home screen. So I need A times, go back in the matrix, B, but I need to transpose B, so I have to go to matrix, go over to math, and my second option is that tiny little t, and I hit enter. So now if I look at this, I get a 1 by 2, and I shouldn't be surprised that I get a 1 by 2, because my solution should be a 1 by 2. Okay, so I'm going to get 690 and 1,666. My units, this is the cost, and this is the day of the week, so Friday and Saturday. So, in words, what does this actually mean? Well, this is just the amount of money made each night. Total money made each night. And that's all you need to do. Okay. Let's look at our third and last example. Now there are 3 parts to this. It's going to take a little bit longer. So it says the first matrix gives the amount of each type of candy in the different size boxes. The second matrix gives the amount of each ingredient in the different types of candy. And the third matrix gives the unit cost of each ingredient. So I'm going to call this matrix A in my calculator. I'm going to do the second one as matrix B, and the third is matrix C. It's always nice to do this so when I'm actually writing out what I need to type in, I make sure it corresponds correctly. Before I do anything in my calculator, I want to start to label these. This is a 4 by 4 matrix, which is a pretty large one. This is the, if we read up there, the type of candy by the size of the box. So that's the labels I'm going to use. My next matrix is a 4 by 3, which again, it's the type of candy by the ingredient. I'm just going to abbreviate that. And the last one is the cost of the ingredient by the actual ingredient. Again, I'm just going to abbreviate that. Now I'm going to take a little time. I'm going to pause the video and type all these in so you don't have to watch that right now. Why don't you pause the video as well and type in each of these into matrix A, B, and C. Hopefully you now have matrix A, B, and C typed into your calculator. So this is why it's really important to have all your labels, because it's going to get more complicated now that I don't just have 2 matrices, so I automatically know which 2 to multiply together. So the question says, how many total units of ingredients are in each box size? So if I look, they care about ingredients and box size. That's going to be the clues to let me know which matrices I need. Well, there's only one matrix that talks about box size, and that's matrix A. Okay, so I know I have to use matrix A somewhere. So I'm just going to put that down here. Now I'm going to use A. I know A is a 4 by 4, and it's the type of candy by the size. Okay, so that's going to help me out. And I know I need to match it up somehow. Well, if I look here, I need to have ingredient. This one has ingredient, and so does C. So how do I know which one it is? Well, B talks about type and ingredient. C talks about costs and ingredient. So if I look here, I know I need to have something match up. Size in it isn't in either of those. So it must match up with type. So that means I'm going to have to use matrix B. So I know I'm going to have to multiply this by matrix B, but let's see if these match up right now. This is a 4 by 3, so the numbers match up, but this is type by ingredient. That's not going to work. The only way this is going to work is if I can transpose my first matrix. If I transpose it, this becomes a 4 and 4, which I can't tell the difference. But then this switches, and it becomes size times the type. And now my types match up. So I know I'm going to have to transpose my first matrix. So I'm going to go to my calculator, which they're already typed in, and go to matrix A. I'm going to transpose it, so go back into matrix, go over the math, times, and then go into matrix, and go to letter B. So I actually get a huge answer, which again, we shouldn't be surprised because I know my solution is going to be a 4 by 3, okay, and it's going to be size by ingredient. So I'm going to draw a 4 by 3, so that means 4 rows and 3 columns. Okay. So I'm just going to write in your solutions exactly how you see it in the calculator. Okay, so just be careful that you don't write any of them wrong. Okay. Because the hard part about grading this section when you guys get to the quiz and test is I don't get to see your work. This is really the work I'm looking for. It's pretty much all you can show me. Everything else is in your calculator. So if you get a wrong answer and I don't see anything like this, I don't know if you got it wrong because of how you typed it in, or if you got it wrong because you don't understand what to transpose. So that's my actual solution, my product, but I need to label it. This is going to be size, so I know it's small, medium, large, and extra large by the ingredient, which is chocolate, nuts, and sugar. Okay, and that's all you need to do. Now, I just want to show you some tricks you can do to save you time, especially on bigger problems where you might need to use a matrix that you found. Anytime you have a matrix, so if we look at this one, I don't have to retype this in if I wanted to keep it. There's a store button down here, STO with an arrow. If I hit this button, I can take my answer and store it into any matrix I want. So right now, I know I'm not using, let's say D, because I know I have A, B, and C. If I went to store and I went to matrix and I went to D and I hit enter, what the calculator does is if I go to matrix D, it now took that answer and put it in there for me. So if you ever need to use a matrix or you want to keep a matrix, instead of having to do this again, you can always use that store feature, which is going to be very helpful when we get to some tougher problems and some trickier questions. So let's go to the second question. Okay, I have all the same information, my orders and my labels, but now it asks what is the total cost for each type of candy. So now I need cost and type. Well, I know matrix C, this is again my matrix C, is the only one that deals with cost. But I need cost and type of candy. Well, this is cost and ingredient, so I need to match up the ingredient. Well, ingredient matches up right here with matrix B, and I can use this one for type, ingredient, and cost ingredient. So let's use matrix B and matrix C. So let's see if I have to transpose any of them. Right now, the middles don't match up. Okay, and I want to know cost and type of candy. So I want the type and the cost on the outside in order to get that. So if I transpose C, I'm going to get a 3 by 1, which is ingredients by cost. If I leave B the way it is, it's a 4 by 3, so the 3's match up, and it's type by ingredient. So now I know my numbers and my labels match up. So I'm going to go back to my calculator. All I need to do is type in matrix B times matrix C, and then I'm going to transpose that matrix. Okay, hit enter, and now I get a 4 by 1, which is exactly what I should get, a 4 by 1. So I'm going to write this out. I have 17.6, 8.3, 12.6, and 14.3. If you're not getting those answers, but you're doing exactly what I'm doing here, make sure all of your matrices are typed in correctly. So now I have to label it. This stood for the type of candy. So we had Rocky Road, cream caramel, toffee, and butter crunch. And this is the cost. So that's all I need to write. And that would be our final answer. So let's go to our last example. So it says, what is the total cost? So now we're dealing with cost again. for each box size. So I need cost and box size. Well, the only place where there's cost is right here in matrix C. Okay, so I know I have to use that. And the only place there's a size is in matrix A. Okay, so I know those are the two matrices I need to use. However, this is a 4 by 4 and a 1 by 3. I can just look at the orders without even looking at the units and know that I can never multiply these together. So how could I possibly come up with this answer? Well, this is one of those more complicated problems where I'm going to have to use matrix B somewhere to help me out. I know ultimately I'm going to need to have the total cost and the size. So that means I'm going to have cost and size on the outside numbers and have something matching up on the inside. So we can start anywhere we'd like. Okay, so let's say we had, here's cost, so I know I need that one. The only thing this matches up with is matrix B. Okay, so I know that I can multiply these two together because we just did this in the last problem, right? In the last problem, we took matrix B and multiplied it by matrix C transposed. And when we did that, we got an answer. Okay, we got an answer, okay, that gave us type by the cost. So if we had a matrix that was a type by the cost, that would actually help us out here because then I can match up the types and then I can get size by cost. So how can we do this easily? Because I want to use this answer again. Well, I just did that problem. Now, if you cleared it, you could always just retype this in. But I know I need this. Here's the answer. So I'm going to use that kind of trick and store it. I'm going to take that answer and store it in matrix D, because I didn't need the other D, so I'm going to put this in matrix D by going down to 4. So now I don't have to type that in my calculator. This answer is in matrix D. So this is my matrix D. Okay, it is a 4 by 1. Okay, so let's look at this. My 4 by 1 matrix D is type by cost. And I know now I need to use matrix C because that's the other one with cost and ingredient. But I need to come up with my type and cost, but I need to get somehow the box size. Well, that's actually matrix A. So I know I'm going to have to multiply this by matrix A somehow. But A is a 4 by 4, and it's type by size. Well, that doesn't match up. What could I do? Well, I could transpose the D matrix. If I transpose the D matrix, I'm going to get a 1 by 4, and it's going to be cost by type. If I multiply that by my A matrix, which is a 4 by 4, that's type by size. So now my 4's match up and the types match up. And I'm left with a solution that's cost by the size of the candy box. And that's exactly what I'm looking for. So I'm going to go back to my calculator. I'm going to clear out the screen. I need to take matrix D, which I've now saved in my calculator. You could type it in by hand, but that store key makes it much, much faster. I need to transpose that matrix, and then I'm going to multiply it by matrix A. And sure enough, I get a 1 by 4. Now I can't see the whole 1 by 4, so let me show you what you're going to actually have to do in a second. So I know my solution should be a 1 by 4, and I'm going to get 188.6, 338.7, but I can't see the next number. That dot, dot, dot in my calculator tells me that if I scroll to the right, I can see the rest of the answers. It's just too big for the screen. Next is a 457.9, and my last number is 679. How do I label this? Well, my 1 came from cost, and my 4 came from size, my small, medium, large, and extra large. And that is how you deal with a more complicated problem. That's why labeling the units and the order is so important. And using that store function, that store key, will make life a lot easier for the more difficult problems. Hopefully now you feel a little bit better about transposing a matrix in a calculator, understanding when you need to transpose, and multiplying matrices together on a calculator.